The next thing we're going to learn is what's called the product rule. You use this if you're taking the derivative of two functions that are being multiplied together and not added. So the derivative of a product of functions, which is this, is equal to the derivative of the first function times the second plus the first function times the derivative of the second. That might sound very confusing, but it's actually not that hard to do, and I'm going to walk you through step by step how to do it in example 4. So the first thing to do is identify both of our functions. So one function is right here, and I'm going to call that g of x. The other function is this one, and I'm going to call that h of x. So I've got one function f of x that's made up by multiplying two functions together. So I have f of x is equal to g of x times h of x, which means the derivative, f prime of x, is equal to the derivative of the first, so g prime of x times the second function, plus the first function times the derivative of the second. And so now all we're going to do is replace our pieces. It might help to also color code it to make things a little bit easier. And so we have that f prime of x is equal to, and g of x is x squared plus 1, so x squared plus 1 prime times x cubed plus 3 plus, and g of x is x squared plus 1 times the derivative of x cubed plus 3. And again, those little apostrophes stand for derivative. So we get that this is equal to, and the derivative of x squared is just 2x. So times x cubed plus 3 plus x squared plus 1 times the derivative of the green piece, which is 3x squared. And now what you do is just multiply everything and combine like terms. So we're going to get 2x to the fourth plus 6x plus 3x to the fourth plus 3x squared. And now we're just going to combine any like terms that we see. And so we get 5x to the fourth plus 3x squared plus 6x. And this is the derivative of our original function. And I know what you're thinking. This is a lot of work, and there has to be an easier way. For this particular problem, I actually think there is, and I'm going to show you how to do it. So way 2. So we have that f of x is equal to x squared plus 1 times x cubed plus 3. Now we can just distribute that right away, and we can get x to the fifth plus x cubed plus 3x squared plus 3. And so this is f of x, so now we can just take the derivative of that, and you get 5x to the fourth plus 3x squared plus 6x. And you'll notice that we get the same thing as our original problem. So in this particular example, the second way might have been easier, but there'll be problems in the future where you can't just distribute stuff out. For example, when we start dealing with trig functions, you can't do that. So now on your own, I want you to try to use the product rule to differentiate this function. Alright, let's go. So we get f prime of x is equal to, and before I do this, I definitely want to identify my functions. It makes it a little easier. So I'm going to call that g of x, and I'm going to call this h of x. So we get the derivative of the first times the second plus our first function times the derivative of the second function. And so now the derivative of our first function is just 8x cubed. And then we rewrite our second function plus we rewrite the first function, and the derivative Oh, this should have been a derivative sign. And then the derivative of this is 20x. And so now we just multiply everything, and we get 80x to the 5th plus 16x cubed plus 40x to the 5th plus 100x. So we combine any like terms that we see, and we get our answer is 120x to the 5th plus 16x cubed plus 100x.